So you're doing algebraic proofs today. So you've already solved these equations. You should already know how to solve them. You're just putting the reasons why you can solve them that way with the problems. So a proof, and we'll do some more proofs as we go through the unit, but a proof is a justification, logically valid, and based on initial assumptions, definitions, postulates, and theorems. Okay. So there are different kinds of proofs. You can have a paragraph proof, and that's where you write it out in sentences, and then you can have a flow chart, but the one that we're going to do is a 2-column proof. So you always start with the given. Okay? So every single problem will say given something. And sometimes you'll have more than one given. You could have 2 or 3 different givens, but those are always the first things that you start with. And then you're always going to end with the prove. So whatever you're trying to prove. So your very last statement should be whatever you're trying to prove. Okay. And so the thing about a proof is you have to write out every single step. You can't assume that you know anything. Okay, you have to write out every single thing. So if somebody picked up the paper and they read your proof, they would know exactly what you did and why. Okay. So there are a bunch of different reasons for these proofs, but our most common ones that we're going to use today are these first ones right here. So when we solve an equation or something and you subtract from both sides or you add from both sides, you're doing that because of the addition property of equality or the subtraction property of equality, or if you multiplication property of equality, etc., etc. And then the distributive property, of course, that's when you have your parentheses and your distributive. But then some other ones, the substitution property says if A equals B, then A can be substituted in for B, and B can be substituted in for A. Okay, so if you're taking something and you're plugging it in, that's substitution. Reflexive property just says A equals A. So like if you get 7 equals X, that's the same thing as saying X equals 7. Okay? And that's called the reflexive property. So again, we already know that, but you can't just assume that whoever's reading your proof knows that. And then the symmetric property says, oh, just kidding. This is a symmetric property. Reflexive property really is A equals A, so X equals X, 4 equals 4. Sorry. And then symmetric is when if A equals B, then B equals A. So if 7 equals X, X equals 7. And then transitive is if A equals B and B equals C, then A equals C. So if you have two things, so A and C, both equal B, then you can assume that they equal each other. Okay? So if X equals 5 and 5 equals Y, then X equals Y. So two things equal the same thing, they equal each other. Questions? Okay. And you won't use all of these for every single one, but let's see what we got. So if we look at this first example, we are given 3x plus 12 equals 8x minus 18. And we're trying to prove that x equals 6. So in these problems, they give you an equation and they give you the answer. So you have to prove how to get there. Okay? Do what? No. Like you're solving it and then your very last thing is going to be your answer. So if we look at this, 3x plus 12 equals 8x minus 18, that's what they told me. So that is my given. Okay, you always start with the given. Okay. So then if I look at my next step, now I have 12 equals 5x minus 18. Well, what did they do to get from statement 1 to statement 2? They subtracted that 3x from both sides. So then the reason would be subtraction. and I'm just going to say POE. So subtraction property of equality. Okay. Questions? Alright, so our next one, we're going from 12 equals 5x minus 18 to 30 equals 5x. How did they get from 2 to 3? They added that 18 over. So addition. POE. Okay. So they subtracted the 3x to get the statement 2. They added the 18. And then how did they go from 30 equals 5x to 6 equals x? Good. So they divided both sides by 5. So division POE. Any questions on that? So your reasons are kind of like one step down. So like on this one, we subtracted 3, but 3 was our next reasoning. So you're not necessarily saying what you're doing in that line. You're saying what did you do to get to the next line. Okay. So then our last one, 6 equals x, x equals 6. That is symmetric property. It's POE also. Questions? Alright, let's do one on our own. So in this next one, we have 3 times 5x plus 1 equals 13x plus 5, and we're trying to prove that x equals 1. So the very first thing we do, we'll make our little table. So we have statements, and we have reasons, so your first statement is always what they give you. So our first statement is our equation here. So 3 times 5x plus 1 equals 13x plus 5. And our first reason is given. So you always start with what you're given. Now you just solve it. So if I wanted to solve this, what should I do next? Distribute. So if I distribute, 3 times 5 gives me 15x plus 3 times 1 is 3. And then we said that we distributed, so that's the distributive property. And the distributed isn't a property of equality because you're only distributing on one side. So you're not, doesn't happen to both sides, it's just one side. Okay. So then from here, there are 4 ways that you can solve this. So your proof might not be the same as somebody else's proof, but you might still, well, you will still have the same answer. Okay. So if you solve it differently than somebody else, that's okay. So how do we want to solve this one? What do we want to do next? Good. So we can subtract the 13x.
Please excuse this interruption at this time. All juniors need to report to the theater. Again, all juniors need to report to the TA. Thank you.
Bye. You'll be back. You don't have to take stuff. So we subtract. I was like, really? Subtract 13 from both sides. So 15 minus 13 will give us 2x plus 3 equals 5. And again, we subtracted that 13. So subtraction, POE. What's my next step? Good. Subtract 3. And then what would be my last step? Good, divide by 2. So, when you have exactly what the proof says, then you're done. So our proof said x equals 1. We have x equals 1, so we're finished. Questions on this first? Alright, let's do this second one. So this one is a little bit different because we have two things that we're given. So some things will list all of the givens as statement 1. But I like to list mine as two different things. So the first thing that it gives me is that 4t minus 6u equals negative 6. And then the next thing that it tells me is that t equals 2u plus 4. So in this one, we're trying to prove that t equals negative 18. So if I'm looking at this, I know maybe it's been a minute since you solved systems, but what can I do with this t equals 2u plus 4? So I can take this 2u plus 4, and I can put it in for that t up at the top. So then that'll be 4 times 2u plus 4 minus 6u equals negative 6. So you're taking what t equals, which is 2u plus 4, and you're plugging it in. And that's called the substitution. POE. And then what should be my next step? Yeah, so we're going to distribute. So we take this 4 and we're multiplying it by the 2u and the 4. So then that gives me 8u plus 16 minus 6u equals negative 6. And that's the distributive property. Any questions so far? So since I knew that t was 2u plus 4, you can't solve an equation with 2 variables. So that's why you have to have a system. So then I took that 2u plus 4 and plugged it into the first one. Yeah. Okay. So then what should be my next step to solve it? Yeah, so combine like terms. Good. So then 8u minus 6u will leave us 2u plus 16 equals negative 6. And then we just combine like terms. Then what should I do? Yeah, subtract the 16. So negative 6 minus 16. Yeah, good. Negative 22. And again, we got there because we subtracted. So subtraction. POV. Then what? Good, divide. So if we divide by 2, we get u equals what? Good. So division. POV. So were we trying to prove that u equals negative 11? No. We're trying to prove that t equals negative 18. Yes, good. So now we want to take this u equals negative 11 and we can plug it back into our second given and then that'll tell us what t equals. So t equals 2 times negative 11 plus 4. Okay, so we're just taking that negative 11 and plugging it back in. So that's substitution. So what should I do first to simplify this one? 2 times negative 11. So negative 22 plus 4. And so on that one we just multiplied. But we didn't multiply to both sides. So it wouldn't be multiplication property of equality. It would just be multiplication. So then in my last step, negative 22 plus 4 is negative 18. And so you could call this one addition. You could call it combining like terms. Either way is correct. So I'm just going to say addition. But again, we didn't add to both sides. we just added on that one side, so it's just addition, not property of equality. Question.